Okay. Today we are graphing when A equals 1. So these ones we are going to graph all the way by hand, and we are going to find our specific stuff because I think that is a manageable thing for us to do. Thursday, when we graph when A is greater than 1, we are going to use a different method. You could use this method, and there's actually a bonus question where you can use this method, but I figured for today, for the ones that we're doing by hand, let's just do these ones where A is 1. So here are our steps. Step 1, we are going to find the axis of symmetry in Vertex, just like we did in 6.5. So we are going to go down to our first example, and we are going to do that just like we did in 6.5. So moving down, this example is a little bit different because we don't have that middle term. So in this problem, my A value is 1. My B value is 0, because I don't have a B term. And my C value is negative 9. Okay, I need to find my axis of symmetry and my vertex. My axis of symmetry is going to be x equals negative b over 2a. Always. That's the formula I'm always going to use. But in this problem, my b value is 0. So I'm going to have negative 0, or positive 0, it really doesn't matter, over 2 times 1. 0 divided by anything is 0. So my axis of symmetry is x equals 0. I put 3 examples on this? Yeah, I did. Okay. I was making sure I had 3 examples, not just 2. Okay, then, just like we did in the assignment we were working on, we're going to plug that in to find our y value. So we know the x value of our vertex is 0. We are now going to do 1 times 0 squared minus 9 to find my y value. You could do that in your calculator, but also I know 0 squared is just going to be 0. So it's just going to be 0 minus 9, which will just be negative 9. I'll go ahead and do it in my calculator for good measure. 1 times 0 squared minus 9 is negative 9. Okay. The steps say to graph everything at the end. I like to graph as we go. So I am going to graph as we go. So 0, negative 9 is a ordered pair. I'm in the middle of doing notes right now, so I'm not able to check an assignment or help you.
I was gonna tell you that I won't be in 6 hours.
Okay, I'm literally recording a notes video right now.
Sorry, I didn't know.
Okay, let me pause the video. Alright, so 0, negative 9. So I like to graph as I go. That is my vertex. That is going to be the middle point of my graph. Any questions right now about finding or graphing my vertex? Okay, I normally also graph a dotted line for my axis of symmetry. I'm not going to do that on this one. We'll do it on the ones on the back. This one we don't really need it because the axis of symmetry is the y-intercept, or the y-axis, so. Alright, next thing that we're going to do is step 2. We are going to factor using 5.6, this should actually say or 5.7, and find the zeros like we did in 6.1 or 6.2. That's my bad. I didn't put both sections on. Damien, make sure you're taking notes with us, please. Alright, so now, moving down, I'm going to look at this problem. I've got x squared minus 9. All of the problems I'm giving you today are the easier to factor ones. It is going to be significantly less time consuming to factor than to try to do quadratic formula. So for x squared minus 9, that is difference of squares. The square root of x squared is x, and the square root of 9 is 3. So my factored form is x plus 3 times x minus 3. So I'm going to factor it out right there. And then, since these are going to be our factored ones with just an x and a number, I didn't leave space for us to solve them because you can solve these in your head. X plus 3 equals 0 when x is negative 3. X minus 3 equals 0 when x is positive 3. Okay. Then we can go ahead and graph those. So we're going to come on our x-axis. We're going to put a point at negative 3. We're going to put a point at positive 3. And those are our zeros. So we found our vertex. We found our zeros. The last step, any questions right now? Okay. The last step would be to find our y-intercept. In order to find a y-intercept, that is going to be on your y-axis. So you will plug in a 0 for x, since all of the x values on your y-axis are 0. So we would plug in a 0 for x. So I'm going to go ahead and do that down here. So I've got 1 times x squared. So 1 times 0 squared minus 9. That's the exact same thing we already did here. It's going to be negative 9. And we actually already have that graphed. So this is one of the problems I was talking about, that coincidentally your y-intercept and your vertex are the same thing. So on this one, we only have 3 points, and we can go ahead and connect them, and we're done. So we are going to connect this. When you connect it, sketch it into a U shape, not a V shape. Just kind of sketch a little U around it, but don't just go a straight line. So we're just connecting the points we have. And then I like to put arrows at the end because it keeps going for forever. All right, any questions on that guy? All right, I skipped over telling you steps 4 and 5. Step 4 was to plot everything, which we already did. We did the axis symmetry, the zeros. The y-intercept ended up being the same as the vertex. And then the mirrored y-intercept. Man, I really forgot a lot of stuff in here. I didn't include we should also plot the vertex. So axis symmetry, vertex, zeros, y-intercept, and mirrored y-intercept. So we'll do this y-intercept and mirrored y-intercept on the ones on the back. And then we sketch our parabola through the points. Any questions right now? Okay, you guys are the first class I'm doing this with, and I regret putting this one first. I should have put this one last. So let's flip this over. We'll see the ones on the back, and they will have all of the parts and pieces. All right, next one I've got x squared plus 4x minus 5. I have lines for A, B, and C. My A value is 1. My B value is 4. My C value is negative 5. Okay, to do my axis of symmetry, I'm going to do x equals negative b over 2a. Negative b over 2a. So that's going to be negative 4 over 2 times 1. So that's going to be negative 4 over 2. Negative 4 divided by 2 is negative 2. Any questions about finding that axis of symmetry? Okay, I think I watched all of you guys do at least one of those on your axis of symmetry assignment, so I believe in you for that. At this point, I'm going to go ahead and graph that. So I'm going to draw a vertical dashed line at x equals negative 2. Because that is going to be where the middle of my graph is. Then I'm going to plug that negative 2 in to find the rest of my vertex. So I've got x squared, that'll be negative 2 squared plus 4 times negative 2 minus 5. I'll go ahead and throw that in our calculators. Negative 2 squared plus 4 times negative 2 minus 5. I get negative 9 once again. In order for graphs to work, there's only so many numbers that you can have your vertex be. So negative 2, negative 9. So my x value is negative 2, and then I plugged that in and got negative 9. We are going to go ahead and graph that. So go left 2, down 9, put a point there. Okay. Any questions about finding that vertex? Okay. We will go ahead and factor to find our zeros now. So on this one, when we factor, we are trying to find two numbers that multiply together to be negative 5 and add together to be 4. What are the only numbers that multiply together to be 5? 1 and 5. It's a prime number, so the only numbers that multiply together to be 5 are 1 and 5. If we want one of them to be negative, and we want to add to be positive, we want the big one to be positive, we want the little guy to be negative. So my factored form is going to be x minus 1 times x plus 5. Okay. If that's my factored form, my zeros are the opposite. So x minus 1 equals 0, so my zeros are positive 1. X plus 5 equals 0, my other zero is negative 5. Okay. So then on our graph, on the x-axis, we can put a point at negative 5 and positive 1. What do you guys notice about those 2 points and our axis of symmetry? Okay, so they're 6 apart from each other. How far are they from the axis of symmetry? They're 3 on each side. So see how they're an even distance from the axis of symmetry? Because our graph needs to be symmetrical. So that's setting us up for success. Okay, last thing that we're going to do on this one is find our y-intercept. So we would plug in 0 for x. So it's going to be 0 squared plus 4 times 0 minus 5. What's 0 squared?
0.
What's 4 times 0? 0. So 0 plus 0 minus 5 is just negative 5. Your y-intercept, when in standard form, will always just be c. Always c in standard form. You got to be in standard form for always to be c, but if you're in standard form, it's always c. Okay, so we are able to graph our y-intercept, so that's going to go on our y-axis at negative 5. Okay, there is one more thing that we have to do on this one, and that is that we are going to reflect, because we know we want to be symmetrical, that y-intercept. So you look at where your axis of symmetry is, and that's why I draw the dotted line. And we say my y-intercept is 2 to the right. So I go back to my axis of symmetry, and I go 2 to the left, and I put a dot there, just to keep things symmetrical. And then I can connect that into a U. So this one has 5 points. This is the normal version where we have everything. Okay, any questions about that example? Okay. The only new part of today is finding your y-intercept, because you guys already knew how to find your axis of symmetry and vertex from yesterday. You already knew how to find your zeros from Unit 5 and Unit 6. We've done those twice each now. And then the only new part is your y-intercept, and it's always just C. You don't even have to do your work for that if you don't want to. All right, last one we've got. We've got f of x equals x squared minus 4x plus 4. My a value is 1. My b value is negative 4. My c value is positive 4. To find my axis of symmetry, I'm going to do x equals negative b over 2a. My b value is already negative. So I'm going to have the negative from the formula, and I'm going to plug in negative 4. So I've got negative 4 over 2 times 1. Negative 4 is positive 4. So I've got 4 over 2. And 4 divided by 2 is just 2. So this one has an axis of symmetry at 2. I'm going to go ahead and sketch that in, because I know that's where the middle of my graph is going to be. Okay. Once we get our axis of symmetry, we can go ahead and plug that in to find the rest of our vertex. So we know that the x value of our vertex is 2, because we know that's where the middle is going to be. We'll plug in 2. So we'll have 2 squared minus 4 times 2 plus 4. Go ahead and throw that in your calculator. What did you get? I don't think anyone's actually typing it in. Okay. So I also got 0. So that means our vertex is 2, 0. So that is correct. Our vertex is 2, 0. So this right here is our vertex. That's going to be the middle of our graph. Okay, then we are going to factor to find our zeros, which we kind of already know our 0 because we literally already just graphed it, but we're still going to factor. So we are looking for 2 numbers that multiply together to be 4 and add to negative 4. What numbers multiply together to be 4? So 4 and 1, but are those going to add to negative 4? Okay, what else multiplies together to be 4? 2 and 2. So if we use 2 and 2, and we both make them both negative, negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. So that's going to be our factored form, is going to be x minus 2 times x minus 2. It's the same thing twice. So this one actually only has 1 0. So if we were to solve both of these, we would get 2 on both of them. It's the same thing twice. You can leave them both. You can cross one off. I don't care. When you go graph it, you would graph the same thing twice. And look, we already have a point there. So on this problem, your vertex and your 1 0 happen to be the same thing. Connecting this all the way back to 6.3, if we were to have chosen to do this one with the quadratic formula, and we would have found our discriminant, b squared minus 4ac, we would have gotten that our discriminant is 0, so our discriminant is equal to 0, and therefore we have one solution. So this all connects together. We're just only doing so much. So don't stress out too much about that. Yeah. Right. And then our y-intercept, since we are in standard form, our y-intercept is always just c. So our y-intercept here is 4. So we will graph that. So 0, 4. And from our axis of symmetry, we have a point 2 to the left, so we need to do another point 2 to the right. Okay, and then we will connect that back into a U. Okay, so I could only fit 3 examples on here, so we only have one example where we have all 5 points. This is when we have all 5 points. If your zeros happen to be your vertex, then those points are all the same. So this one only has 3 points because your zeros and your vertex are the same. On the front, the first example we did, this one only has 3 points because your vertex and your y-intercept happen to be the same. So you could have up to 5 points. I think on your assignment, 3 of the problems have 5 points and 2 of the problems, so 1 problem like this and 1 problem like this. So, any questions at the moment? Okay. I think the only way for you to understand it is the only way to understand it is to go through it. So, when I give you your assignments, start finding your axis of symmetry, start factoring to find your zeros. Your y-intercepts are always C. Put it on the graph, and when things look wonky and you need help, let me know and we can help you. So, plan for the rest of the day is just work on this assignment. We got 36 minutes left, should be enough time. There's only 5 questions, so that's all I could fit. Okay, I'm gonna stop this recording. It's a hot mess of a recording already.